Seen from afar, Venus is beautiful, bright, mysterious, second only to the moon in brilliance as it graces Earth's early morning and twilight skies. It has long been called Earth's twin, similar in size, similar in mass, a neighboring world that, perhaps, once held promise. But up close, that promise dissolves into a nightmare. Venus is not the tropical paradise early astronomers once dreamed of. It is a world drowned in atmosphere, so dense, so hot, so toxic, that it crushes and cooks anything that dares to land on its surface. It is, quite literally, an ocean of gas. Not one of water, but of pressure, heat, and chemical fury. This is the story of why Venus's atmosphere is one of the most terrifying places in the solar system, and how it may hold the key to understanding not only our planetary neighbors, but Earth's possible future. The first thing to know about Venus is this: its atmosphere is not just thick, it's overwhelmingly thick, composed primarily of carbon dioxide, with clouds of sulfuric acid and trace amounts of nitrogen. The atmosphere stretches nearly 250 kilometers above the surface. The pressure at ground level? 92 times greater than Earth's, the equivalent of being nearly a kilometer under the ocean. In fact, if you were to stand on the surface of Venus, something no human has ever done, your body would be instantly crushed, your spacecraft melted, and your electronics fried. You wouldn't even see the landscape, only a thick, murky yellow haze as dense as soup. Venus doesn't have an atmosphere. It has a smothering ocean of gas, where every meter closer to the surface deepens the pressure, like descending into an abyssal trench. It's this immense weight of atmosphere that makes Venus feel less like a planet and more like the bottom of an alien ocean. But pressure is only part of the nightmare. Venus is the hottest planet in the solar system, hotter even than Mercury, despite being farther from the Sun. At the surface, temperatures reach a staggering 475 degrees Celsius, hot enough to melt lead. How? The culprit is the atmosphere itself. The dense carbon dioxide traps heat in a runaway greenhouse effect. Sunlight filters through the upper atmosphere and strikes the surface, but the outgoing infrared radiation gets trapped, bouncing back and forth within the thick clouds, heating the planet like an oven with no escape vent. And there is no relief, not at night, not at the poles. The planet rotates so slowly that a single day lasts longer than its year, and thick atmospheric circulation distributes heat evenly, meaning the entire planet, pole to pole, remains a scorching inferno. This is not just a hot planet. It is the embodiment of a greenhouse apocalypse. Above the crushing heat and pressure, the atmosphere churns. Venus's upper cloud layers are home to winds that scream across the planet at over 350 kilometers per hour, far faster than the planet itself rotates. This phenomenon, known as superrotation, is still not fully understood, but it means that Venus's atmosphere moves as a vast, swirling machine, one that circles the planet in mere days. Even though Venus's surface takes over 240 Earth days to complete one rotation. And in those clouds, lightning, flashes of energy burst through the thick sulfuric layers, illuminating the perpetual twilight. The sulfuric acid doesn't just rain, it never reaches the ground. It evaporates halfway down, broken apart by the planet's brutal temperatures. This acidic rain and electric chaos create a storm world, an upper atmosphere laced with electricity and chemistry, powered by a slowly dying engine of heat and pressure. Imagine an alien ocean of gas, acidic clouds, perpetual storms, and no safe harbor. Since the dawn of the space age, humans have tried to visit Venus. Most failed. not because of distance, but because of destruction. The Soviet Union's Venera missions were the first and only to survive the descent. Venera 9 became the first spacecraft to send back images from the surface of another planet in 1975. It lasted just 53 minutes before succumbing to the crushing pressure and heat. Others didn't even last that long. Venera 7 managed 23 minutes. The Americans tried too. Pioneer Venus, Magellan. The ESA sent Venus Express. And now, NASA and other space agencies are planning to return. But every probe that dares to descend into Venus's lower atmosphere faces the same fate: obliteration. No lander has ever lasted longer than 2 hours on Venus's surface. Even titanium melts here. Traditional electronics fail. Solar panels fry. Cooling systems can't keep up. The planet is, in essence, a graveyard of machines, a museum of ambition burned by fire and pressure. Yet we keep coming back, because Venus holds secrets about its past, about its present, and maybe about our own. Venus wasn't always this way. Billions of years ago, it may have had oceans. It may have had mild temperatures. It may have had rain, not of acid, but of water. Some simulations suggest that Venus could have been habitable for over 1 billion years before tipping into its current state. So what happened? At some point, the balance was broken. Perhaps due to volcanic eruptions, loss of magnetic shielding, or orbital shifts, carbon dioxide began to accumulate. As the greenhouse effect intensified, oceans, if they existed, would have boiled away. Water vapor, a powerful greenhouse gas itself, accelerated the feedback loop. And when the water escaped into space, the planet was left dry, toxic, and smothered by its own atmosphere. It is a cautionary tale written in clouds and heat. Venus is not just a hellish world, it is a mirror, a warning of what can happen when a planet loses control of its climate. When balance is lost, even a twin can become a monster. Despite its terrifying atmosphere, Venus has re-emerged as a target of renewed scientific interest. NASA's upcoming Veritas and Da Vinci Plus missions aim to map the planet's surface in high detail and analyze its atmospheric chemistry. The European Space Agency's Envision mission will follow soon after, seeking clues about Venus's volcanic activity and internal structure. Why now? Because Venus may yet hold answers. Perhaps microbial life exists in the more temperate layers of its upper atmosphere, where temperatures hover near Earth-like levels. Perhaps its geology is still active, reshaping its surface in bursts of volcanic fire. Perhaps, by studying Venus, we will learn how climate disasters unfold and how they might be avoided. And beyond science lies ambition. Some dream of floating cities in Venus's upper atmosphere, suspended above the clouds, where air pressure and gravity are similar to Earth. It sounds like science fiction, but for the first time in decades, Venus is drawing eyes, not just as a dead world, but as a world with lessons to teach. Venus is a world shrouded in myth, mystery, and menace. Beneath its luminous beauty lies a landscape of extremes, a deep, thick ocean of atmosphere where nothing soft survives. It is a planet forged in pressure, sculpted by heat, and sealed in clouds of acid. Yet it beckons, because in understanding Venus, we may learn how planets change, how Earth could change, and how fragile the line is between paradise and perdition. So when we gaze at that bright star in the early morning sky, remember, it's not just a planet. It's a warning wrapped in light.